Hello, this is Shakil Ahmed. In this tutorial, we will learn how to produce different graphs using survey design function. Basically, for weighted data, we can visualize data using different graphical functions. So we start with a histogram, that is, we just construct for a continuous variable like we again start with our uh, National Health and Nutrition Examination Survey 2005 to 18, and that is already imported here, and I have already renamed for just for uh, saving time, so we can see frequencies of different variables, and I have just labeled and recorded all the variables we are working on. And then for survey design, we need these packages as we have already discussed in previous videos. You need to install Heaven package and survey JTools, remote and SVR, EPMISC. And then we have a data on a variable weight, that is for the name is WTMEC2 year, means we have a weight for we obtained weight for 2 years, as we have 2 years each of for each cycle, and we have total 7 cycles 2005 to 2018. So the weight is already computed for 2 years, that is coded as WTMEC2 year. You can just see uh, this is your weight variable basically, and using weight variable we have obtained the survey design object that I called it S design SDES, and this is already we have already discussed how we can set the primary sampling unit, stratification variable and weight, and we get the object survey design, and you can see the summary of the survey design as well. Now we are going to construct a histogram for age. That is basically we are constructing on the basis of weighted data. When we talk about histogram can be obtained for class level probabilities as well as class frequencies. So when you run this command svy histogram, you will get a histogram with class probabilities. You can see we have different classes with equal size of bins. We have not set basically bin, we are just running this survey design histogram function, and you can see different probabilities corresponding to different classes. We have a lot higher probability in age group, for example 0 to 3, I think you can see, and 0 to 5 I think, and then 5 to 10, and then 10 to 15, then 10 to 15 to 20. So these are the class probabilities. We can see this is basically a type of relative frequency obtained based on weights, basically weighted relative frequency uh, that are represented on y-axis, and on x-axis we have age. So if you want to replace the probabilities by frequencies, then you can just need to write probability is equal to false. So I am going to run this command, and you will see the frequencies on y-axis now this time, and then we go for box plot. Box plot is also constructed for a continuous variable to show the five number summary statistics, including the minimum value, the maximum value, and the quantiles Q1, Q2, Q3, and the outliers as well. And if you want to include all outliers, then you need to set all outliers is equal to true. So let's see the box plot for age, which include the minimum value is at 0 and the maximum value is at 85, and the median age is I think around 37, as we had already seen above. Using survey weight command we have obtained. So basically we are plotting the survey weighted statistics on this box plot. So this is somehow different. The box plot you just run without setting the survey weight command. So whenever you are dealing with survey weighted data, then you need to display your results using svy command instead of just running a box plot. And uh, I can display the box plot for age for by male and female. So I'm setting the factor as 6, and we can see the box plot for male and female. There will be a comparison. So I am just giving a title as well. We can give a title to the figure we have already constructed above, just with man, and then whatever you uh, want to give the title, you can just write in the inverted double inverted commas. So this is for uh, male and this is for female. So the median age is slightly higher for females as compared to males. And you can construct a bar plot uh, that is for a qualitative variable. Now I am taking two qualitative variables like income and education, and then again taking the factor sex. So I am just comparing the income and education by sex. So let's see, and we are representing the we are obtaining the survey mean. Basically, survey means refers to the proportions of the classes. Here, the variables are qualitative, so you can just see what happened. This is the bar plot, and then uh, b- this is bar PLT, and then you need to use the bar plot for the bar PLT you have obtained in this command, and you can just set the title as well. So I'm also setting the legend is equal to true. It means it's giving a legend, but this legend we need to adjust this legend as well. But for survivability data, you can produce results in such a way, and that is age, sex, male and female, and we have income on three levels and education on three levels. So the first three are for income and the first last three are for education. So this is just a type of multiple bar diagram. So you can compare the survey weighted data, basically survey weighted proportions in different classes with respect to male and female with respect to the gender variable. Similarly, you can draw a box scatter plot to see the correlation between two continuous variables. So with the bubble, basically you are giving the bubble to show the weight for the different cases. For example, you are just checking the correlation between age and income of different individuals, then the weight will be associated, will be represented by the size of the bubble. You can see. So this is we have a very huge data set, basically around uh, 70,000 observations. If we see, for example, row df 70,190 observations, so we can't see clear uh, about the bubbles and their sizes. So when we have fewer number of observation, we can easily see this bubble plot, scatter plot using the bubble. Basically, here bubble size, if the bubble size is larger, then uh, it means the case or the dead case has the higher weight as compared to other case. And then you can make a density plot and smooth plot. Smooth plot means you can just you are plotting a continuous variable on smooth line. Just running a smooth plot for age again. This is a smooth plot for age. Basically, this is just smoothing the uh, uh, histogram just we made by by grouping the continuous variable in different groups with using different bin size. But here the continuous data is plotted and then smooth using smoothing methods. And you can see the density plot, and then bandwidth is means you are just uh, making a curve from maximum frequency to the minimum frequency. And you can write the density plot, that is like just a smooth plot we have already seen, and this will show the distribution of the values, uh, and the probabilities are given on y-axis that are survey weighted. So you can make a lot of other type of visualization. These were the basic visualization tools we need when we are representing the survey weighted data uh, with the survey weighted estimates and proportions and other things. So you can just visualize those statistics you obtain in your survey weighted analysis. You can represent them using visualization tool again with survey weighted object. So thank you. If you have any question, you can always write in comments. Take care.